Hello and welcome back. In this session, we are going to learn to some implementation in Scala. Uh, First, now let's just remind ourselves uh, about the problem statement. Okay, here is the problem statement. Given an array of integers, return indices of two numbers such that they add up to a specific target. Okay, and then we have something here. In the previous solution in Java as well as Scala, Java as well as Python, we exited as soon as we found one pair, basically one solution. But for Scala, we will find the exhaustive solution. That is, we'll check all the numbers. Actually, we did that before also, but we exited the computation as soon as we found the first solution. But here in Scala, we will not exit the computation. We will exit the computation only after we've found all possible combination. For that, we'll add a few more numbers here, because in this particular given uh, array we have only four numbers and there is only one pair that satisfies the target sum. We'll add one more pair so that we know that our implementation is actually looking for more solution, not just one. Okay, all right, so for this particular example, obviously uh, 0 is the index of 10 and 1 is the index of 20, and obviously 10 20 summation gives 30, and the corresponding indices are 0 and 1, and that's the answer. That's what our implementation, if it's a method or function, whatever it is, it has to return their value. Okay, if there are two pairs, then there will be two such pairs to be returned. Okay, so that's about the uh, problem statement. Let's just minimize this and get started with our implementation. I'm going to start my file, and that file is going to be to some app.scala. I think we had to some app.java, to some app.py, this time to some app.scala. All right, and we're going to start object because that's the one that we can compile. We can run object, and object name we need to some app. Okay, and we start main method def main args array of string, and we have nothing interesting to return. Okay, and we close that. We're going to come back to this one, and we first want to implement our main logic, which is how to calculate how to find those suitable pairs. Okay, so we're going to pass a list of integer. Okay, list of integer. This is how we write list of integers in Scala, and then we're going to pass the target sum also, which is also integer. Okay, and we're going to return not just list of integer, we're going to return list of integer, because if you find one pair, we'll have a one pair of indices, and we have two pairs, then we'll have two pairs of indices. Okay, so for that we'll have list of integer. Okay, now we need to define this. So what's our definition? Is for the given list we find all possible combinations of two numbers, because that's what we need to do for this problem. Actually, if I say 3 here, it will look for all possible combinations of three numbers in the given list. If I say 4, it will do 4, but for now we do 2. Okay, and then we say collect. But what are we going to collect? We're going to collect, and whatever we collect, we're going to convert that into list. Okay, but what are we going to collect? We will have a case here. Case x is a variable actually, and it represents each combination. In each iteration, it will represent each pair actually. It'll the logic will come with a two pair each time, and that's what it represents. Case x, case I could say pair, okay, or I could say y. Let me just call it x. It's a common variable in mathematics for that reason. If, and also it might look counterintuitive, but it's also for clarity. If I say pair, or if I say some other give, it might look like a some reserved word, right? So not to be confused with the reserved word. So that we're not using any kind of ready-made kind of program constructs. It's just a variable, okay? And a Scala compiler as well as interpreter, they understand it. If x, case x, if x or somewhere, we need to check this one. This has to be satisfied because that's what we are looking for. We're looking for a pair of numbers in the list that add up to, which sum is basically target. And if that is the case, then what are we interested in? We are interested in something, and that something is x dot map. So those two pairs we map with their indices, and indices don't come from x because x is just in each iteration we just pick two numbers. So yeah, it doesn't retain the indices. So but the indices are available in the original list of integers. So that's where we get the index from. Okay, that's it. That's the implementation. See how it works, like how compact it is compared to both Scala, compared to both Java and Python. Now we're going to create our list of numbers. Nums is equal to list. This is how we'll create list in Scala. And how many numbers we want? 10, 20, whatever we saw here. Let's go back. How many we have? 10, 20, 35, 40. 10, 20, 35, 40, and we want to add a little bit more so that 5, 15, and 25. So we're supplying at least one more pair somewhere, at least 25 and 5 here. That also results a sum of 30. Okay, so that's another pair. So we should expect if the program compiles and runs successfully, then we will get two pairs of indices, and those indices should be, let's get line number here so that it's easy to explain. So those indexes would be, if you look at the line number 3, that's index 0, that's index 1. So first pair will be 0 and 1, and another pair, 35 is a little too high, 40 is a little too high, above 30, so that's not the right combination. I'm going to find among these three. 25 and 15, that's already high. 15 and 5 is not 30, so the right combination is 25 and 5, obviously. And the index of 5 is 0, 1, 2, 3, 4, that's 4, and index of 25 is 6. So index 4, 6, index 0, 1, and 4, 6. Okay, that's what we will be expecting. But let's first complete the program before we can run it. And we need a val my target is equal to 30, val my result. My result is equal to, I need to call to sum by passing my numbers and my target. Okay, that's pretty simple. Println my result. That's it. Okay, let's compile it to some app. Okay, see how many errors we get. We'll fix them. All right, it says, what does it say? Not found type INIT. Okay, INIT is not the right type. We have a typo there, and the correction would be integer. That's the integer. Now let's save, exit, recompile. All right, let's run it now. Do some, that's it. 0, 1, 4, 6. All right, so we got the right answer, and this is our implementation. See how short it is, how many lines. Let's just have line number one more time. See the exact logic, the exact implementation is from line number 9 to line number 13. 1, 2, 3, 4, 5. Actually, it's a one single statement. I can just press backspace and just pull everything here. There are no multiple statements also here. It's one particular statements can give the result. Okay, pretty interesting. Not only that, it is more kind of customizable. Now if I change it to 3, it will give the combination of 3. Let's try that. Since we are already doing it, why not to compile and see and have this recorded here in the video so that we know that it works rather than just saying it yesterday. This time we're looking for three numbers that add up to 30. So what are those numbers? 10, 20, already gone, is already 30. We need three. So 10 looks like one candidate because it's below 30. If I take 20, it's already 30 because I need three numbers. So that's 20 is not a good candidate. If 20 is not a good candidate, 35 is not, 40 also is not. How about 5? 5 is a good candidate. 10, 5, 15. And another 15, yeah, that's a good candidate. And last 25. Last 25, if I take another, it can only take 5 because 25 plus 5, 30. Okay, so we'll get one combination, only one combination. Let's save, exit, compile, and run it. We are expecting 3 indices, but just one pair. Okay, 3, 0, 4, 5. Okay, as expected. Let's go back and see 0, 4, and 5. Okay, so 0 is the index of 10 in line number 3. If you look at line number 3, 0, okay, 1, 2, 3, 4, and 5. 0, 4, 5. That's what we have here, right? 0, 4, 5. All right, so this completes our Scala implementation for the tuition problem. So until we meet next, I will say goodbye.